Hello. In this video, we're going to start looking at logarithmic properties. First, we're going to assume x is greater than 0, y is greater than 0, a is greater than 0, and a is not equal to 1. Okay, so with all that covered, let's go ahead and look at the product property. So the product property says log base a of m times n is equal to log base a of m plus log base a of n. Now what this tells me is that when you have a single logarithm with a base that's valid and the argument has multiple factors that are being multiplied, or in this case 2 being multiplied, you can just add them together with 2 different logarithms with that same base, and each of the factors getting their own argument. The quotient property is very similar. We have log base a of m divided by n will give us log base a of m minus log base a of n. Now, same thing, except we have division of 2 different factors. So we have the numerator in the first logarithm minus the denominator in the second logarithm. Now for the power property. We have log base a of m to the pth power. This will be p log base a of m. In other words, when we have an exponent, it can come outside the logarithm as a coefficient. Alrighty, now this is very useful actually. Looking at this example, we have expand using the properties of logarithms. Write the answer without exponents. So here's what we have. We have log base 2 of xy squared all over z cubed. I'm not going to go through all the processes to show you how we get here. I'm just going to go ahead and tell you the answer. The answer here is I'm just going to tell you what the answer is, and then I'm going to go back and talk about how we get there. So we have log base 2 of x plus 2 log base 2 of y, then minus 3 log base 2 of z. That's the answer. And I fully expect you to be able to go from here to here immediately. And here's why. First of all, if it's in the numerator, that's going to give you a positive coefficient. If it's in the denominator, that will give you a negative coefficient. And the coefficient is the exponent for the variable. Now, what I mean by this is each of these factors, each of these variables gets its own logarithm. So we have log base 2 for each of the logarithms guaranteed. We have 3 different ones, so we have 3 different logarithms. The variable x, the variable y, the variable z, they all get the argument by themselves. The question is what about the coefficient? Notice that the x and y are in the numerator, so they're both positive coefficients out front. The z is in the denominator, so it gets a negative coefficient. Now looking at the exponents, notice that the x has an exponent of 1, so technically there is a 1 times log base 2 of x there. The exponent on the y is a 2, so that's a 2 log base 2 of y. And the exponent on the on the z is a 3, so that's a minus 3 log base 2 of z. Now that you see this, hopefully you can tell what I'm doing, because this is actually very nice, because you should be able to begin with the question and just write down the answer. Okay, I'm going to go ahead and end the video here. I will see you in the next one. Have fun.